Okay, we'll go ahead and get started. Let me go ahead and open up in prayer, and I'll give you a sense of the material we're going to be covering for today. So, dear Heavenly Father, Lord, thank you for the chance to be working with each of the students in this course, Lord. Pray that all of the material that they're getting a chance to be exposed to here at APU is enjoyable, that they're able to understand it and they can see the clear relationship between the technical material that they're covering and ultimately their goals of getting the position or opening a company of their own that they desire. I pray that you would help them in their spiritual formation, Lord, that all the times that they're getting a chance to be studying scripture, that it would be uplifting, edifying, and that they can be storing away those nuggets of a better understanding of your word, dear Lord, and also the theological concepts in which we want to be guiding our life by. Give them interesting and creative ways for faith integration. In Jesus' precious name, we pray. Well, today's lecture is going to be something that's pretty closely related, the fact that we open in prayer. And so we're going to be talking about ethics. And so of course, the textbook is more written from an engineering point of view, but last week we got a chance to get a perspective that, I would argue this is engineering and computing ethics. And so that would be something to have in perspective. And so if you read what the description is for this course, there's a few things I want to be pointing out since we're going to be talking about ethics. And so it covers the impact of engineering and computing solutions in global economic and societary context, case studies of effective civic, governmental, and social engagements in engineering and computing ethics. And so here we specifically are going to be talking about ethics. And so I'm glad that it comes up. And so we're going to cover the material that's in the textbook, but I've also supplemented it with a couple of videos that I think will be helpful. But before we get into some of the beginning part of this lecture, I'd want to have us do this icebreaker. And also just as a heads up, so on Thursday, I would like to spend a little bit of time that you guys can talk about some of the project proposals that you had so we can get a chance to have a conversation. And we had last Tuesday a good conversation about some of the things that people would like to be getting out of this course. And I'm going to make a survey that you guys can actually type it into Canvas. And so I haven't had a chance to do that, but that would be something I'd also like to get your feedback. But let's think about this in terms of an icebreaker, engineering and computing ethics. And so as it reads here, write a few sentences that respond to the following prompt. How do you define ethics? Instead of writing it down, let's go and have a discussion. Discuss what you know about engineering and computing ethics and ethical conduct. So how would you define ethics? I don't know if you guys have read the chapter yet, but what do you think? What is ethics? Also, being in a Christian university, you're getting a chance to get more insight than some, I would argue, but I'm going to talk about that specifically to introduce the idea of Christian ethics. But what does the word ethics mean to you, or does that bring up for you? Any thoughts on that? I'm not trying to stump you either, so don't feel bad if you can just off the top of your head.
First word that comes to mind is being fair.
Yeah. Mhm, mhm.
Not favoring maybe like other companies over others or other coworkers.
Mhm.
Just being fair.
Yeah, being fair. We've had some discussion a little about what it means to, quote, think like an engineer, think like a computing individual, that mindset, being interested in problems, trying to understand how things work and stuff like that. So if you have that kind of responsibility, and maybe even the word I might use in the near future, authority, when you're designing things, whether it's software, hardware, systems, or something like that. How do you think that would start to apply in that kind of a situation? Any thoughts on that? What about being honest or dishonest? Do you think it would be prudent to be honest? What if you fudge on the numbers and something like that, or you cut corners on your analysis and the bridge fails or something like that? Or I can have like a video from the NASA Space Shuttle Challenger that blew up on launch. And I think it might be giving you an example of just failure of things that took place there. Well, a couple other things that I thought of when I thought about ethics. I took a Christian ethics course. I actually teach a Christian ethics course, and I like teaching that. And so it's another layer of a context. But what about things like artificial intelligence? Do you think there needs to be ethics applied to things like that? The moral use of artificial intelligence? Go ahead.
An AI would be for you, this the way some people use AI is like just like do their work for them.
Yeah.
Because
Mm.
it's your ethics, because you're trying to be honest about your work,
Hmm.
and that's kind of like cutting corners to get it through yourself.
Right. Check. Yeah. Well, yeah, like, getting on that, misinformation is like making fake videos, having people say things they didn't say. And it's getting harder and harder to figure out if it's real or not, you know. Chat GPT, there may actually be courses in your field that may actually be closer, like Dr. James Ye. Unfortunately, he had to move on. He's not here this year. But what he talked about is you could be using it for helping you to write code. So say like you have like one of the courses I teach is computer architecture, and I have people get a chance to explore Arduino units. And so write a Arduino script that turns on an LED, and whoop, it'll create the code for you. Well, you could think as a student that may not be something you would want to do unless you have that concurrence with the class that's as part of what you're trying to do. But you have some very basic code and you're trying to do a larger perspective of what you're developing, that could actually be a useful tool. So like you said, you want it to do things that are good and not for evil. Different area, but more in biology, gene editing. That's an area where, what about the ethics of cloning? You can think there's just a lot of different areas that it starts to come up. And so we're going to be touching a little bit on that by thinking about the material in this chapter. And here are the objectives. Engineering ethics, explain what is meant by engineering ethics. We'll have couple of different things that we're going to look at. The Code of Ethics for the National Society of Professional Engineers. So it'll be over several pages, and you can be getting a chance to read it a little bit more in detail in the textbook. And so it gives examples of fundamental canons and rules of practice. So even in a non-Christian setting and just a secular mindset, they have to think of rights and wrongs, so what to do and what not to do. And that almost goes counterculture with where some of the directions of where some of our society is trying to have us go. Engineering creed, explain what is meant by the engineering creed and give example. Makes me think like the Apostles' Creed. Here we're thinking of a creed for engineers and computing. And academic dishonesty, conflict of interest, professional responsibility, explained what each of these terms mean. Anybody heard of the term conflict of interest? So say like you have a government official, they're not supposed to have any bias. And so if they have stock in a certain company, and that's one of the companies that they have in their portfolio that they're contracting with, that would be called a conflict of interest. So if you're making a decision, it needs to be clear that you're going to be unbiased in what you're doing. So that's just a little bit of perspective. We're going to be focusing on engineering and computing ethics. but I'll also be talking some about Christian ethics as well. So what is engineering ethics? Ethics is the field of morality and the moral choices that we all must make in our lives. So professional societies such as medical and engineering have long established guidelines, standards, and rules that govern the conduct of their members. So this goes beyond just, what is legal versus illegal. It's what's moral, what is ethical. All of these are things that we want to be considering. These rules are also used by the members of the Board of Ethics of the professional organizations to interpret ethical dilemmas that are submitted by a complainant, okay? And so here are some of the societies with codes of ethics. And so the National Society of Professional Engineers, the American Society of Mechanical Engineers, the American Society of Civil Engineers, and the Institute for Electrical and Electronic Engineers, just to mention a few, but that just gives you some representative set. I didn't fix this by looking up some of the societies for the SWE or something like that, or some of the computer science ones. So, but there are there as well. So why is ethics important in engineering and computing? We talked a little bit about that in the beginning, but maybe there's a few more words that you guys might have. Why don't we just do away with all this and we just assume that we're going to be doing a good job? Do you think there needs to be accountability? Yeah, checks and balances. Just think of like recently the Boeing Crew launch vehicle that went up to the ISS, and it had a couple leaks. It had a hydrogen leak, and one of the thrusters wasn't working. Would you want to go right back down to Earth in that and potentially risk having you die going through reentry? It just gives you an idea. Here are the kind of challenges that we have. What about all the software? I'll just keep on theme on that. What about all the software that Boeing had to write? And somebody got a little bit lazy with their code, and it turns out that they didn't do their units conversions right. And so one person was using meters and another person was using feet. Guess what? That's going to cause problems too. Like all other professions, engineering requires honesty and integrity from its employees. Codes of ethics allow them to take responsibility for their actions. They serve as a standard for deciding what is right or wrong. Engineers must adhere to a code of ethics to ensure they always act truthfully in their business dealings. And when you're in the professional world, there'll be various types of training and things that you'll have to sign, trying to ensure that you don't have a conflict of interest and getting into this area. So all of those things exist. So this is one of the textbook I use in a class that I have had a privilege to teach a couple of times on Christian ethics. Wayne Grudem, has anyone ever heard of Wayne Grudem? It may be an author that one of your classes, you may have a theology class, it may have a textbook by Wayne Grudem. He has a systematic theology textbook that's pretty well known. This is another textbook on Christian ethics that is written in the same fashion, kind of like a handbook, and you can be exploring specific issues where you might want to be thinking about what would be the Christian perspective. Let's pretend like it's World War II and you're in Nazi held part of the world at the time, and you have Jews in your attic, and the Nazi patrol comes to your front door and they ask you if you have any Jews in your home. What are you going to say? And how are you going to ethically be able to say one thing or another? Do you think it would be ethically okay to say, no, I don't in that situation? Right. So it's like, what is the greater good? You're trying to protect life, and these people are usurping even the nation of Germany. There were problematic rationales and how Hitler came into power, but I'm not going to get into that. And so this is a short video by Wayne Grudem, who is the author of that book, and you'll get a chance to think a little bit about Christian ethics.
And try to reason to some conclusions. But a Christian approach takes into account God and the Bible. And we believe as Christians that God is in charge of the universe. He is the one who is sovereign over our lives, and he has the authority to tell us what is right and wrong. And so a Christian approach to ethics takes into account God and his presence, but also his words to us in the Bible, because there he has told us about ethical decisions, about moral right and wrong. And so a Christian approach to ethics comes with the authority of God rather than just merely human opinion. In addition, a Christian approach to ethics realizes that it isn't just words from God and then we obey them. It's also in daily activities, we are to live our lives in the presence of God, aware of his presence with us, and aware that we are accountable to him and we should seek to please him in all that we do day by day. That's a completely different concept than a secular approach to ethics.
So it's not a matter of like what I can get away with. You know, we have a higher calling. You know, there's an absolute right and wrong that we defer to. And so it's a powerful thing. It's none of us are going to be perfect. And so we're trying to, we all fall short of the glory of God. And passage in Romans that maybe you're familiar with, that we can be thinking about this context. So that's a little bit of something for us to think about. What is the nature of ethics, thinking it from a Christian perspective. And then we have a couple of examples of codes of ethics. And so here is a code of ethics of the National Society of Professional Engineers, and it goes over several pages. So you have, I'll just quickly go over and then go into more detail. You have a preamble, fundamental canons, rules of practice, professional obligations. And so these are the things that they wanted to make sure that are covered. So in the preamble, engineering is an important and learned profession. Engineering has a direct and vital impact on the quality of life for all people. So we want to be thinking about where we have a chance to impact the lives of others. And it's not just engineers, computing, computer science. Engineers must perform under a standard of professional behavior that requires adherence to the highest principles of ethical conduct. And what could be higher than to be looking at God's word as the basis for how we're going to determine that. Fundamental canons, engineers in the fulfillment of their professional duties shall is a contractual statement. If in a couple of years, you'll probably be exposed to this. That's contractually binding. And so there has a special thing, and an engineer who's familiar with requirements would have a sense of that. So shall hold paramount the safety and health and welfare of the public, shall perform services only in an area of their competence, shall issue public statements only in an objective and truthful manner, shall act for each employer or client as faithful agents or trustees, shall avoid deceptive acts, and shall conduct themselves honorably, responsibly, ethically, and lawfully, so as to enhance the honor, reputation, and usefulness of the profession. In terms of rules of practice, engineers shall hold paramount the safety and health and welfare of the public. Engineers shall perform services only over their competence. Engineers shall issue public statements only in an objective and truthful manner. Engineers shall act for each employee or client on a faithful agents or trustees. Engineers shall avoid deceptive act. And so we have the fundamental canon. Here we're seeing how we're supposed to do that. So there's some repetition of the material there. And then professional obligations. Engineers shall be guided by all their relations by the highest standards of honesty, integrity. Engineers shall at all times strive to serve the public interest. So to think of that, it's not only our calling as in the Christian context, but also even in our professional world, we want to be seeing how we can impact in a positive way the public. Engineers shall avoid all conduct and practice that deceives the public, and engineers shall not disclose, withhold consent, confidential information concerning the business affairs or technical processes or of any present or former client or employee or public body on which they serve. So you're not supposed to learn something from one company, go to another company and tell all their intellectual property and devoid all of these things in terms of confidentiality of what's going on with the design or approach. Then there's the statements from the NSPE Executive Committee. Engineers and firms may individually refuse to bid for engineering services. Maybe they're being manipulated in one form or another. You can say no as well as say yes, maybe not even to bid. Clients are not required to seek bids for engineering services. Federal, state, and local laws governing procedures to procure engineering services are not affected and remain in full force and effect. State societies and local chapters are free to actively and aggressively seek legislation for professional selection and negotiation procedures by public agencies. And then continuing on, state regulation boards, rules of professional conduct, including rules prohibiting competitive bidding for engineering services, are not affected and remain in full force and effect. We're supposed to honor and respect the laws of the land. State registration boards will, with authority to adopt rules of professional conduct, may adopt rules governing procedures to obtain engineering services. And reflecting what from the Supreme Court, nothing in the judgment prevents the NSPE and its members from attempting to influence government action. We can seek to influence laws if we think that they don't align with the way things should be, or there's something that's missing, there's new technology that needs to be thought of and how it's going to be governed. All of those are things that are out there. So what do you think? Engineers should avoid what kind of acts? Deceptive? So engineers shall not falsify their qualifications. So you can't lie on your resume. You want to brag, but that you don't want to lie, and you want to represent in the most positive light, or permit misrepresentation of their or their associates' qualifications. They shall not misinterpret or exaggerate their responsibility in or for the subject matter of prior assignments. So honesty is key. This would be something from the textbook. I would understand if maybe you haven't seen this part. In which year was the engineering creed adopted by NSPE? Probably, I'll just put it up, 1954. So the second one. So a creed is a set of fundamental beliefs or guiding principles. The engineering creed was adopted in 1954. Okay, check something here. So here I don't know why this divider is after this. So we have dishonesty, conflict of interest, professional responsibility. So for academic dishonesty refers to behavior that includes cheating on tests, homework assignments, and lab reports. And what I've heard it said is like, if you're cheating, you're actually cheating yourself, because I'm personally, this may sound strange, I'm not a big fan of tests. That's not how things are done in the professional world normally, unless you're trying to get some type of certification. And so, but really getting a chance to do real project work and showing your skills, that's how it's normally done. But you don't want to be lying, even lying about sick. It's okay, maybe physically, mentally, there are various ways of how you can be interpreting this, but not like you take sick leave and then you go skiing or something like that. That's like a misuse of that. Plagiarism, Now with Chat GPT, there's a whole nother layer where it gets a little bit sticky, unless that's condoned as something that is possible to do. And then signing the attendance sheet for another student or asking another student to sign the sheet for you in your absence. That's just another example of something you want to do. Plagiarism is presenting someone else's work as your own. You may use or cite the work of others, including information from journal articles, books, online sources, TV or radio, but make sure that you cite where you obtain the information. That's important. Conflict of interest. This is a conflict between the individual's personal interest and the individual's obligations because of the position they hold. Okay. You have stock in a company. You're working for two competitors at the same time. That shouldn't never happen. But some people that aren't acting in an ethical fashion, that has actually taken place. The government at times has figured that out, and there's been huge fines. And that's something that your company would not want, and you're going to be losing your job and could be facing criminal prosecution. For contracts, a contract is an agreement among two or more parties. A legal contract is one that is legally binding, meaning that if not fulfilled, it could have legal consequences. You could get sued if you don't, for breach of contract. Professional responsibility, it's associated with the mastery of special skills of knowledge. The use of knowledge for well-being and the benefit of society. All those things are things to be thinking about. So here's a recipe, 7 steps for ethical decision-making. Some of this is going to sound a little bit like the engineering steps. So state the problem, consider appropriate facts, identify the stakeholders, develop a list of options. It sounds like a analysis of alternatives, test the options, make a decision, and then you can verify, does this make sense? If you go along this path, you can see that it's going forward. So it's rigorous, it's repeatable, and it's a consistent process. So the next slide, I'm going to be showing you this video from the space shuttle disaster that took place. It's a little bit long, but I think it's worthwhile getting us to get a chance to hear an example of when things start to run amok, and who would ever have thought that this would have been something that NASA would have experienced.
I'm Alan J. McDonald, and I am currently an aerospace consultant and author of a book called Truth, Lies, and O-Rings Inside the Space Shuttle Challenger Disaster. At the time of the Challenger disaster, I was the director of the Space Shuttle Solid Rocket Motor Project for Morton Thiokol, the manufacturers of the large solid rocket boosters on the shuttle. I'm going to discuss the Challenger accident, how the launch evolved, what happened to the Challenger during its launch, and some of the inquisition that happened as a result of the investigation by a presidential commission on the accident. The Challenger disaster happened on the morning of January 28, 1986. It took place on pad 39B at the Kennedy Space Center in Florida. I received a telephone call from a fellow that worked for me. And he said, Al, he says, we were just told that there was a weather forecaster, I believe in Orlando, that was forecasting a cold front in the area of Florida that might drop temperatures as low as 18 degrees Fahrenheit by tomorrow morning. And we're really concerned about whether the O-ring seals and these fuel joints, the solid rocket booster, will operate at those temperatures properly. And I said, well, I'm very concerned about that too. They said, Al, what you need to do for us is get a hold of somebody at Cape there from NASA to find out what they're projecting hour by hour all through the night at the launch site, not in Orlando, so that we can calculate what the actual temperature will be on various parts of our boosters by the opening of the launch window. I says, I will get that information and call it back to you. But I said, when you get it, here's what I want you to do. I want you to get the engineers together and have them make an assessment of their concerns of the cold temperatures on the sealing of those O-ring seals. And I would like them to make a recommendations, what is the lowest, safest temperature to launch that we can tolerate? And I want that decision and recommendation to be made by the Vice President of Engineering, not program management. I felt that that was a thorny technical issue and should be decided on its technical merits only. And as a result, I requested that the Vice President of Engineering make that recommendation. So I called the NASA rep there and arranged for that teleconference that evening. And it was a three-way teleconference between the engineers in Utah, those of NASA in Alabama, and our management at the Kennedy Space Center in Florida. So it was not surprising to me that after the engineers presented their information, the Vice President of Engineering came on just as I requested and recommended they do not launch the Challenger below 53 degrees Fahrenheit, which was primarily based on that observation of that flight a year earlier. The NASA management really didn't accept that conclusion and felt that if we're going to change the launch commit criteria, we needed to anchor it in something better than just this qualitative observation. And here was a condition which we had claimed as, in our opinion, going in a direction that may well cause a failure, a very catastrophic failure. And so what happened is that my boss, Mr. Joe Kilminster, who was the Vice President of Space Booster Programs, came on the telecon and asked for a 5-minute offline caucus to make sure that we had presented everything that we had available to us and see if we could better analyze the joint to determine if there was a lower temperature that was safe to launch. What really surprised me was that when the management of my company came back on a half hour later on the teleconference, it wasn't the Vice President of Engineering anymore who made the recommendation not to launch below 53 degrees Fahrenheit. It was my boss, the Vice President of Space Booster Programs, Head of Program Management. And he said that they had reassessed all of their data and they have concluded that it's okay to proceed with the launch as planned. No restrictions at all, no temperature.
Does that sound a little bit funny? You know, like, your customer says you're not so sure about this, but the chief technical folks, they said, no, this isn't safe. And so now all of a sudden, a different part of the company comes in and says, no, we're gonna change our point of view.
Requirement whatsoever. Well, NASA reaction was that, well, they accepted that without any question, but they needed that recommendation put in writing and signed by a responsible THIACOL official. Well, I knew who that responsible THIACOL official was. That was me. That's why I was there. And I made the smartest decision I ever made in my lifetime. I refused to sign it. Now, I didn't think it was totally unethical that the NASA people questioned how we arrived at that decision and the data we presented. What was unethical is they knew that we had a moral obligation to always prove it was safe. And what they had just done was put the engineering people in a position to prove that it would fail. That's a totally different question. You're never supposed to do that. And in fact, the final decision, which I didn't know at the time, I found out later, was that the general manager decided not to listen to the engineers who still felt that it was too risky and tried to convince him not to change the decision, even though he thought that NASA had some good questions and he kind of agreed with them. He decided that he was going to pull his management team, which ended up as only the vice president, as to whether we should launch or not. Now, this was at the time all unknown to me because I was back at the Cape, but I was so disturbed with the change in the launch recommendation, and we were waiting for the written recommendation to come back from our plant in Utah, that I turned to the NASA management people and I said, you know, I really don't feel comfortable with that decision. I don't agree with it. But more importantly, you cannot even accept that recommendation. And they says, what do you mean, Al? I said, you cannot accept it because you know, and I know, that you're asking us to fly those solid rocket motors outside a temperature that's been qualified to fly in. And you can't do that. You can't fly any of the shuttle hardware outside of its qualification limits. That's against protocol, so you can't accept it. I'm recommending launching, not based on what I know, but what I do not know, and you're in exactly the same position. And I said, Al, you know, these shouldn't be your concerns, but we'll pass them on in an advisory capacity only. And they said, where's this fax that's signed by your official? And so it happened the fax machine was the other end of the building, so I went down there, and it took a while to come in, but I finally brought it back. And when I brought it back, they were in a teleconference with one of the people on the mission management team. Since I was gone for 15, 20 minutes, I presume they talked about the O-ring issue earlier. And I was shocked to find out later they never mentioned it. Well, I remember getting up early that morning of the launch, and I was carrying my briefcase in one hand and my headset in the other, going to Launch Control Center. And I remember hearing on the radio it was 22 degrees Fahrenheit at the time. I went into the Launch Control Center and sat down at a console that I am supposed to be at to monitor all the data on the solid rocket boosters. And in the corner of that TV monitor that I have, they have access to various cameras that are on the vehicle that you can punch in and look at. I remember I started looking at some of the cameras, and I noticed there was ice hanging on the vehicle. There was ice hanging on platforms next to it. And I quickly concluded to myself, well, they're going to launch this thing today. And the next thing I noticed was several minutes later, they decided to send an ice team out to the launch platform to knock down as much of the ice they possibly could and take it off the mobile launch platform because they're concerned of debris. And they did that. And after they did that, they picked up the count again, and they finally made another stop in the count to go back and send the ICE team again to relook at the launch pad, and they did, came back and concluded that it was okay to proceed with the launch, which really surprised me, but they did. Now, I really expected if the O-rings would fail because of cold temperature, they would do that right at ignition when you would light these solid rocket boosters. Strangely enough, some 73 seconds later, the whole vehicle looked like it had exploded in the air. And I was watching it on the TV camera with one eye on the pressure tracers of solid rocket boosters and the data we were monitoring. And it was absolutely shocking to everyone who was in the control room. I could hear some people actually sobbing in the background because they knew that this was unsurvivable. I went to Huntsville, Alabama, the Manassas Marshall Space Flight Center next morning to be part of the failure analysis team NASA was forming on the solid rockets. And I was about convinced that, yeah, this was caused by, in my opinion, I thought it probably was a cracked turbine blade and the space shuttle main engines finally came loose because they were having that problem and went through the tank, and that caused the explosion, or the tank structurally came apart and exploded. And I was ready to leave and go home. So I've been gone for about a week, and I actually walked out the door and was heading out the door. And this fellow from NASA that I argued with the night before, the name of Larry Malloy, said, Al, you need to get back in here. I says, why? He says, well, you've got Jim Kingsbury, the Director of Science and Engineering for Marshall, that's at the Cape looking at some movies and films of the launch. And he claims he can see some fire coming out of the side of one of your solid rocket boosters just before the explosion. My heart sank when I saw the actual launch film because I thought, you know, it probably did happen exactly for the reason we were concerned the night before the launch. the O-rings were too cold. And it wasn't until President Reagan decided to form a presidential commission where the real answers came out. And primarily from me, not NASA. What had happened is I stayed and worked on that failure team, and within a few days, I presented to NASA exactly how the Challenger failed. And it was due to the cold O-ring issue that we had addressed the night before. It just manifested itself in a final failure quite different than we expected. But that's why it really failed. It was clear they didn't want to hear that. What had happened was one of the NASA people in Washington, who was a budget analyst, had sent a memo he had written to the New York Times. And it was about this problem that we had with this O-rings and the joints. Well, at that time, NASA had never briefed the Presidential Commission on anything that caused the accident at all. They knew nothing about it. And yet, it was almost a week earlier, I briefed them exactly what caused it. So they scheduled a closed hearing that afternoon with NASA. Well, NASA wanted all my charts that I had given to headquarters the previous summer, and I gave it to them. I remember going up to this briefing, and it was in the old executive office building next to the White House. And the NASA folks made it very clear they were going to give the entire briefing. No one else needed to make any comments unless they were specifically requested to do so. And the fellow's briefing was a fellow I argued with, and he was going through these charts, and he briefed for about an hour and a half. And the commission asked for a break. They took a break. They came back, and I remember Dr. Sally Ride, before she sat down, she was thumbing through a bunch of clean telephone slips. She says, before we get back to the briefing, the guy with me, I'd like to ask you a question. I returned a few of my phone calls. And one of them was some reporter here in Washington that asked me if it was really true. They'd heard a rumor that one of the contractors may have been concerned about the cold temperatures affecting their hardware. Maybe even recommended not launching. Is that really true? In fact, he said we had a teleconference about their concerns of the projected temperatures on the field joints and O-rings. And as a result of that teleconference, we had all our engineers and communication with all our engineers in Alabama and management at Kennedy, and reviewed all that. And as a result of that conference, Martin Thiokol recommended that we proceed on with the launch as planned. And they submitted a written statement to that effect. You know, back to this briefing. And I thought, well, I guess that's a true statement, but that is about misleading as anything I ever saw, and was certainly unethical. And so I finally started walking down the stairs towards the conference table that the commissioners were sitting at. And Mr. Larry Malloy was giving this briefing, was giving one of the charts that I'd given him, in fact, that morning. He was being asked some questions about it. He said, I think Alan McDonald has something to add here. As I think this commission should know that Martin Thiokol was so concerned about the projected cold temperatures on our field joints and O-rings that we recommended not launching below 53 degrees Fahrenheit. I remember Chairman William Rogers, who was the head of the Presidential Commission, and his vice chairman, who was Neil Armstrong, and Dr. Richard Feynman. They all kind of stood up and kind of peeked at who this guy was coming down here. And William Rogers was the ex-Secretary of State under Nixon and Attorney General under Eisenhower. And looked at me and he says, well, who in the hell are you? He said, would you please come down here on the floor and repeat what I think I heard? Because if I heard what I think I heard, this will be in litigation for years to come. My life changed when he said that, because I knew who was going to be in the middle of all of this litigation for years to come. Me. Looking back at all the decisions and things that happened, there's two criteria I always look at with regard to ethics. There's ethics that are associated with having to make tough decisions, tough pressure, time constraints in that environment. And then there's those that aren't, which I consider those frankly are the worst ethical issues. And both of those occurred in the Challenger decision. I'm proud of what I did. As far as ethics was concerned, the biggest breach of ethics was the fact that both my company and NASA attempted to cover up what really happened that night before the launch. And there was obfuscation by NASA on what really caused the final accident, which I went over with the Presidential Commission before they filed the report, and they agreed with me. And to me, that was a bigger error than the pressure at the time to launch from breach of ethics, because they had time to think about it and deceive people. One of the big disappointments I had after going through all that, and a lot of the lessons that were learned from Challenger and were fairly well implemented immediately after, but they carried over to a point where they finally were forgotten some 17 years later. But when they launched the Columbia that year in 2003, they clearly saw on the film this huge piece of foam, it's called ramp foam off the tank, impact the orbiter. And it actually impacted the leading edge rather than under the pile in the shadow. They then ran some analysis of what that impact damage could be, and they had the fanciest, most up-to-date computer model there was available at that time in 2003, and concluded that the damage wasn't significant enough that they couldn't return home safely. There were some engineers at Langley that didn't feel comfortable that that was the case and said, well, we can find out for sure by asking the Department of Defense to turn one of their spy satellites towards the orbiter in orbit, facing towards it, and it will see it in space. If it has significant damage, that it would be a catastrophic reentry. So they made a specific request to the mission management team to do that. And it so happened that the mission management team declined that request on the basis that they'd had an analysis done by Boeing on this crater model computer program that was the most fancy thing in the world, and that they don't feel there was adequate damage, so they didn't need to go through the protocol and make a request to make these pictures. It was the first time in the 50-year history of NASA that I saw they went from a can-do attitude to a can't-do, and that was the most serious mistake, the most unethical mistake I think they probably made in their entire history. One of the lessons learned I tell students also is, don't always believe in all your big computer programs. Use your gut feeling and some back of the envelope, just a reasonableness checks on some of those answers, because that will give you far more confidence. And I'll tell you, some people have better judgment just saying, you know, it doesn't smell right. And you need to do that. And so that's the other lesson learned. And don't presume anything. If you think it's important, make sure that what you thought was important got to the right people. So that's what I wish I would have done.
I know that's kind of a long video, but I thought they did a nice job with it, so. Any thoughts or comments on what they talked about? Did you see some of the ethical dilemmas and things that came up? How would you have handled that situation if you were if this individual and you were asked to say whether or not it's safe to launch? Would you have done the same thing he did? Mm-hmm. So this is in an engineering context, but there would be plenty of computing context I could have talked about as well. But I thought this was the neat thing I've said about NASA is very open. And so it's very transparent in terms of itself as an organization. So the good and the bad, it's all under public record that they have to report out on all of that. So he actually alluded to a second shuttle accident that took place at the very end, but the main thing they talked about, it was just too cold to launch, and management went over the head of the engineers and says, yes, it's okay. Largely due to that's what NASA wanted to have them say. And so they did change their approach. And since then, there's been a lot of times when launches have been scrubbed because there's a lot more scrutiny to make sure that something like this doesn't happen. But of course, you never want this to happen in the first place. That's why manned crewed operations into space, it's a lot more checks and balances rather than if you're just going to be launching a satellite and if it blows up, you just build another one. You can't replace people, and so that's definitely something else that to be observed. Did you find that video helpful? Is that something? Okay. At least some of you guys, I hope maybe the majority, but I thought it was worth taking the time. So as a result, I'm not going to really focus on too much of the rest of this stuff. Here's something that the textbook mentions, the ethics. Here's an ethics context. Engineers A works for company X and is owned by which is owned by engineering B. Company X is currently experiencing financial problems, and engineering B recently created another company, company Y. Engineering A has learned that engineer B recently advised clients of company X to remit payment for work performed by company X to its employees at company Y. What are engineers A's ethical obligations under the circumstances? I'm not going to try and troubleshoot that, but you can see that there's clearly some conflicts of interest kind of things that are going on to be concerned about. And so there's a couple of different cases. There's another one from that ethics context that's laid out. Here's an academic qualifications scenario. So are you properly specifying what kind of degree that you have? Like, for example, it's a way that you can be saying your degree is you can be saying Bachelor of Science in Computer Science, and then in parentheses, estimated graduation date, blah, blah, blah. So you can put that in a resume, but you're stating that you're still in the process of doing it, but also giving the credibility that you're taking this degree program. So here's another example of misstating credentials. You don't want to be doing that. So using technical proposals of another without consent. So that's a breach on multiple perspectives. It's not ethical, it's cheating, it's misrepresentation. All of those are things that you don't want to be doing. So here, a blank is an agreement among two or more parties that they entered into freely. Yeah, contract. Or contract is agreement among two or more parties that they entered into freely. A legal contract is one that is legally binding, meaning it is, if not fulfilled, it could have legal consequences. And thus that word shall is important. The requirements of what is stipulated in the contract that must be done. And so at least from an engineering sense, shall is an important word. So that's the synopsis for that chapter. I'll just go back to the beginning. And so we talked about engineering ethics, code of ethics, an engineering creed, and academic dishonesty, conflict of interest, and professional responsibility. Any questions or observations on some of what we covered there? So you can see there's more than engineering and computing than just being a good programmer or being good at design. And so here we've had this first 5 lectures that we've been focusing on the robustness of that, what it means to be an engineer or in computing. And then we got a chance to be talking about the importance of communication, both written and oral. And now we've got a chance to be talking about ethics. So we're gonna have a little more than half a dozen lectures that are going to be getting into some engineering fundamentals. I also would be curious to see how I could temper a lecture or two, or maybe more, with some computing centric ideas. And so I'd be interested to hear what your thoughts are. Maybe it has stuff to do with things like artificial intelligence or Chat GPT. We could figure out something that would be on the lines of cybersecurity. Like I can give you a cybersecurity example. I'm try to remember the name of the company. It's actually a Russian company that did kind of like McAfee or Norton. Begins with a K. I forgot what was the full name, Casperry or something like that. And so what it turns out that they were actually once they got a presence and people were starting to trust them, they actually introduced viruses where they were exfiltrating data back to Russia. That's what I heard. And so it was just definitely a breach of ethics for what they were trying to accomplish. So having backdoors in software, is it ethical for people to be putting cookies that are using soliciting information without your permission, exfiltrating what you're going to, not only for your website, but other websites? You know, that could be getting into some of these other areas that might be worth thinking about. But it's up to you to communicate any of the ideas that you have that you think would be interesting to think about the computing side. You guys a lot of you, at least I think more than half are on the computing side. So I want to have stuff that would be of interest for you. Any other, go ahead. The next lecture, sorry, is going to start here in part 2. And so it'd be fundamentals dealing with things like dimensions and systems of units. But also Thursdays is more of our lab time. So I want to be spending some time going over what you have for your project proposals, and let's see if we can start to see some common themes. And so maybe if you could all come prepared to literally just do a summary of that, a couple of minutes. And I'd like to spend some of our time on Thursday doing that. Does that sound good? Okay, well, I think that's probably a good breaking point. I'll check and see if there's anything else that I missed here. Okay, well, you guys have a wonderful evening, and I'll look forward to seeing you all Thursday. Take care. Have a good one. Take care.